Hello, lovely 3H students. Today we're going to talk about transforming quadratics, AH and K transformations. Hopefully this is review, but I do really want to focus on what AH and K do on a bigger scale because this is going to apply to all of the different mother functions we talk about. So what is a mother function or a parent function? It is the simplest function that represents a family of functions. So for example, when we're talking about a quadratic, the simplest, most basic version of a quadratic is just simply x squared. So we would call this the mother function of the quadratic. You want to get really comfortable with what this graph looks like. You also want to get really comfortable with what the basic table of this looks like. So when I plug in -2 squared is 4, -1 gives me +1, 0, 0, 1, 1, 2, +4, right? So get really comfortable with these three things. This is the most basic version of a quadratic function. Right. Vertex form of a quadratic, which is why we practiced last converting to vertex form, tells us a lot of really fantastic information. So we talked about this last time, it can do three different things to the function. It can stretch it, make every output taller. It can compress it, make every output shorter. It can flip the function or reflect it over the x-axis if it's negative. So a couple things that A can do to a function. H is going to shift your function left or right. So that's the value attached directly to that x that will shift your function left and right. And then K is going to shift our function up and down. So when we look at the example here, we have 1/2 times x minus 4 squared plus 3. Our A is 1/2. So this is going to compress our function. Every output will be half as big as it used to be. So it's going to be half the height that it would have been before. H in this case is a +4 because look at the equation over here. When we look at this equation, we subtract. So if you still see the subtraction sign, the actual H value is positive. So this has a positive H value of 4. K is on the outside and it is what it looks like. So this is a +3 K value. So we will shift right 4 and up 3. My new vertex would be at +4, +3 compared to the original mother, which has a vertex at 0, 0. So that's how that function would be transformed. Okay, so as I just said, if you have an A value that's a fraction, something less than 1 but greater than 0, it's going to shorten. So let's just think about what we said before. So if we have x and y for the mother function x squared. So this is for my mother function x squared. Well, we said we'd have -2, +4, -1, 1, 0, 0, 1, 1, and 2, 4, right? So that's my mother function, most basic version of a parabola. Well, if I have the function, actually, let me put it up here. If now I want to look at the function 1/4 x squared, and I create my xy chart, well, now each of these outputs that I have over here, each of these outputs is going to get multiplied by 1/4, right? So we've done all the squared business. Order of operations says I do that first. So now all I have to do is take all of those mother function values and I'm going to multiply by 1/4. So when I plug in -2, I'm going to have 4 times 1/4. When I plug in -1, I'm going to have 1 times 1/4. 0, 0 times 1/4, so I don't really need to do that one. 1 times 1/4. 2, 4 times 1/4, right? And we know parabolas are symmetrical about the vertex. So once you know those first 2 points, you know the other two as well, right? All right, so 4 times 1/4 is just 1. So my output here is now 1 when it used to be 4. It's 1/4, nice and squatty, short. Okay, so it's going to look nice and short. And then, all right, so let me go back to that previous one real quick. So each of these outputs is going to be cut by 1/4. So what would have been left 1, up 1 is going to end up being left 1, up 1/4. And of course, parabolas are symmetrical about the vertex, so that's going to happen on both sides. Okay, so what if we have a stretch? So now we have an A value that is greater than 1. A value greater than 1 is going to make every output bigger. So it's going to be taller. It's going to look skinnier, but every output's going to be stretched. We call it stretched. Okay, so I took the privilege of writing down the equation or the table for the mother function, and then I indicated what I would be doing for my transformation here, which is an a value of 5. So now every single output is going to be multiplied by 5. So 4 times 5 is 20. So instead of going left 2 up 4, now we go left 2 up 20, way taller, right? 5 times taller. Okay, over -1, so to the left 1, now we're going to go up 5, and so on and so forth. And of course, these are symmetrical, so this will be 5 and 20, and this is still at 0. So again, every single output is going, we need to apply that a value, that a transformation to every single output of our function. All right, H represents our horizontal shift. And remember, the equation for vertex form has x minus h. So if you actually see a positive, it means we subtracted a negative. That's how we got the positive there. So that means that this is actually h equals -3. So we're going to shift left because it's a negative value. So we're going to shift left because it's that negative value there. In this second example here, now we can still see this subtraction sign, which means that the h value must actually be positive. So this means that h is actually a +3. So this is going to shift us in the positive direction, right 3. K is our vertical transformation. It's going to shift us up and down, and it matches what it looks like in the equation. So -4 means we're going to shift this entire function down 4 units. +4 is going to be a shift up 4 units. So this is k equals -4, and this one would be k equals +4. Okay, we want to convert from graphing form to standard form in this equation. So what we're going to do is take our squared term there, x minus 1, and we're going to do an area model because the most common mistake would be to do x squared minus 1 squared, but it doesn't work like that because you would discount that middle term. So this is going to be -1, x minus 1, x squared minus x plus 1, right? So what we get is 3 times x squared minus 2x plus 1. Then we're going to distribute that 3, and don't forget we need to subtract 8 at the end. So we get 3x squared minus 6x plus 3 minus 8. Again, all I did was distribute that 3 to every term inside. 3x squared minus 6x minus 5 would be my standard form. Again, that's f of x equals. All I did was multiply it out and combine like terms to get into standard form. All right, you do it on this one. Pause, give this your best attempt on your own. Okay, don't forget area model, x plus 2, x plus 2, x squared, 2x, 2x, 4, x squared plus 4x plus 4. So now we need to multiply everything in there by 1/2 because that is my a value. So we're going to distribute that 1/2 to every term inside, and then don't forget to add your 4 at the end. 1/2 x squared plus 2x plus 2 plus 4. So we end up with 1/2 x squared plus 2x plus 6 as standard form of our equation there. Okay, next up, we need to identify the vertex given graphing form or vertex form. We need to state the values of h and k and how they transform the mother function. And then we're going to graph both the mother and the transformation. I would do those in 2 different colors. Okay, so the first thing I want to do here is identify a, h, and k and what they do. So a in this case is 4. It's going to stretch my function. So every output is going to be times 4. We're going to stretch it, make it a lot taller. H is going to be a +1 because I can still see that subtraction sign. So that means my actual h value is positive. So we're going to go right 1. So this is going to shift me right 1. K is going to be +8. That's going to shift me up 8. My vertex is going to be at 1, 8. Your vertex is always at hk. So we're going to go over 1, up 8, and that will be the vertex of my new function. All right, very quickly, let's make a mother function table. So just for the plain old x squared function, if we plug in -1, we get +1. Plug in 0, we get 0. If we plug in 1, we get 1. Okay, each of these outputs is going to be multiplied by 4 in our new function. So when I go to graph this, I need to keep in mind that my new function, every output will be multiplied by 4. But let's just graph our mother first. And again, you could plot a lot more points to get a more accurate parabola there, but that's the basic mother function equation. Now I'm going to start by plotting my new vertex, which is going to be at +1, +8, 1, 2, 3, 4, 5, 6, 7, 8. Right there. And then normally I go over 1, up 1. So that comes from here, right? Normally we would, when we plug in 1, we get out 1. But now everything's going to be multiplied by 4. So when I go over 1, I'm going to go up over 1, up 1, 2, 3, and 4. And that is going to be my new. And then same thing on the other side. Again, symmetrical about the vertex. And look how much skinnier that guy looks. However, he's not skinnier, just taller. So I also would look skinnier if you multiplied my height by 4. I would look a whole lot skinnier. But really what we're doing is increasing these heights. These outputs are being multiplied by 4. So this is taller. It has been stretched. Okay, let's do our next example here. So I know that my A value is -2. This is going to flip or reflect and stretch, right? So this is going to be taller and face the opposite direction, concave down in this case. H is going to be +3. Again, if I still see that subtraction sign, it's a positive H value. K is going to be +1. So this is going to shift me right 3, and this is going to shift me up 1. Again, we know that our mother looks like this. Boop, boop. And then I'm going to start by graphing the vertex of my new function. So again, my vertex is going to be at H, K. So 3, 1. So I'm going to go over 3, 1, 2, 3, up 1. And there is my new vertex. Now this is going to be flipped upside down, and every output will be doubled. So normally I'd go over 1, up 1 if it were the mother, but now I'm going to go over 1, down 2, over 1, down 2, and of course that's symmetrical. And again, if you need to be creating a table for these, absolutely do that. So create a table if you need to. All right, let's look at our next example. So in this case, we have an A value of -1/2. That A value is going to flip my function and compress it. Now every output will be half as large as it would be in the mother. So it's going to look shorter, or it's going to look wider. It will be shorter. Our H value is just 0. Notice there's nothing attached to that x² term. So there is no H value. It's just 0, would not change that. So our H value is 0. And our K value is 3. So my vertex has been shifted up 3, but I haven't shifted left or right at all. Okay, so let's again draw the mother just for comparison purposes. There is your mother function. Our new vertex is at 0, 3, so it's going to go up there. Let me switch colors. And then every single output is going to be half as tall, and we're going to go down instead of up. So normally we'd go up 1, over 1, up 1. We're going to go over 1, down 1/2. Over 1, down 1/2. If you were to plug in 2, the normal output would be 4. Normally we would get an output of 4. So when we go over 2, we go up 4 in the mother. But now we're going to go half as much and down. So when we plug in 2, we're only going to get out -2. So when I go over 2, 1, 2, I'm going to go down 2 only. And again, what we have is a concave down and a squatty. It looks shorter, or it looks wider, right? But really we've just shortened all of these. So again, if you were to cut my height in half, I would look a whole lot squattier, but really you just changed that height. So again, this A value is affecting the height, the outputs. Okay, next example, we have 1/3 of x plus 2 squared. Okay, my A value is 1/3. It is going to compress my function now by 1/3. Every output will be 1/3 as tall as the original. My H value is -2. Again, if I see a positive in there, that means I must have subtracted a negative. So the actual H value is -2. And K is going to be 0 because there's nothing there. I could add 0, same. All right, so my new vertex is at -2, 0. So I've shifted this function left, but I haven't shifted up or down at all. Again, draw out your mothers for comparison purposes. So now we're going to shift left 2 for my new vertex of negative 2, 0. And then every single output will be cut in thirds. So normally I go over 1 up 1. I'm going to go over 1 up only a third. If you think about x squared, if we were to plug in a value of 3 for x, we would get out 9, right? So I'm going to use that one and cut that one in thirds because it'll give me a nice whole number to graph. So 1/3 of 9 is 3. So when I go over 1, 2, 3, I'm going to go up only 1, 2, 3, unlike in the original where I would go up 9. So left 1, 2, 3, up 1, 2, 3. And there is my compressed version, my transformed quadratic. Again, we shifted it left and we made it squattier. So every single output there is 1/3 what it would be in the mother. And feel free to graph these in Desmos if you want to get a clear picture of what's happening here. All right, last but not least, we're going to convert from standard form to vertex form by completing the square. So what we did last lesson, you want to identify the vertex of the quadratic. Tell me what the values of AH and K are and how they transform the function. All right. So the first thing I want to do is take out the greatest common factor here, which is 2. I'm going to take my 2 out and I get x squared minus 2x plus 6. Actually, I think the way that I taught you guys was to originally get rid of this 12, right? So let's do that first. So we're going to subtract 12 on both sides. So now we have y, f of x in its fancy function closes just y, minus 2 equals, and then I'm going to take out a 2. 2x squared minus 2x. And then I'm going to put plus this. Yep. And over here, I'm going to put plus 2 times that box, because remember that what you're actually adding is also being multiplied by 2 there. So whatever you use to complete the square, make sure on the left-hand side, you're also multiplying it by 2. All right, so I know I want 2 numbers that are identical to add to negative 2. So that's going to be negative 1 and negative 1. Negative 1 times 1 is 1, and that is what goes in my box to complete my square. And that goes on both sides, keeping the equation balanced. So now what we have is y minus 12 plus 2, also known as y minus 10, equals 2 times x minus 1 squared, right? We get our factors from here, so we've already done the heavy lifting. And then all I have to do is add my 10 back to both sides. So my resulting equation is y, or f of x, equals 2 times x minus 1 squared plus 10. All right, so what is a in this case? A is going to be 2, and it's going to stretch my function. H is going to be positive 1. It's going to shift us right 1. K is going to be positive 10. It's going to shift us up 10. And my vertex is going to be at 1, 10. That is my vertex. Okay. All right. Next, you're going to attempt this one on your own. Slightly easier because you don't have to take any a values out. So we're going to add 1 to both sides. Y plus 1 plus whatever I'm going to add to complete the square equals x squared plus 6x plus whatever I need to complete the square. I know we're going to add to 6 and be identical. So that's 3 and 3. 3 times 3 is 9. So that's what I add on both sides. On the left, I now have y plus 10. And on the right, I'm going to take these factors and say that that is equal to x plus 3 squared. Now all I have to do is subtract 10 on both sides. So now I have y equals x plus 3 squared minus 10. So a is going to be 1 in this case. It does not transform the function because it's the same as the mother function. H is going to be negative 3. We're going to shift left 3. K is going to be negative 10. We're going to shift down 10. Okay, in this one, I'm going to move my 18 over and then take out a 3. So now I have y minus 18 equals, pull that 3 out, x squared plus 9x plus whatever I'm going to add. And then over here, I'm going to add 3 times whatever that box is because I took that 3 out already. So I'm looking for something that adds to 9 and is perfect, or the same on both sides. So that's 4.5. So this one's a little bit ugly. 4.5. We're going to do 4.5 times 2, and that's going to, or times itself rather. multiplies 2, adds 2, right? Okay, so we want to add up to 9 and whatever we multiply to. So 4.5 times 4.5 is going to give me what goes in that box there, right? Which is going to be 20 and a quarter. So 20 and 1/4, 20 and 1/4. Again, that's kind of ugly, but we're going to factor it out anyway, and you can leave the decimal of 4.5 or 4.5, whatever you prefer. Okay, so over here, we're going to have 3 times 20 and a fourth, right? So 3 times 20.25, and we're going to have that added to our, what do we have, our negative 18. So that's going to give us on the left-hand side y plus 42 and 3/4. And that's going to equal, again, we've already done the hard work here, 3x plus 4.5 squared. And then I just need to subtract my 42 and 3/4 on both sides. That's gone over there. And now I have my equation in graphing form. Ugly, yes, doable, totally. All right, so now what we want to do is write our a value. A is going to be 3. H is going to be negative 4.5. K is going to be negative 42 and 3/4. A is going to stretch my function. Stretch. H is going to shift us left 4.5. K is going to shift us down 42 and 3/4 or 42.75. All right, now you try this one. Y minus 40, move that 40 to the other side out of my way. 5 times x squared minus 2x plus whatever is going to complete my square. Over here, I'm going to do 5 times whatever that is. That's what I'm going to add. Okay, I want it to be negative 2 and be identical on both sides. Negative 1 plus negative 1 is negative 2. Negative 1 times negative 1 is 1. So we're going to add, whoop, that's an eraser. So we're going to add 1 to both sides. But what we're actually adding is 5 because we're multiplying it by 5. So over here we have, we have y minus 40 plus 5, so y minus 35 equals, again, we've already done the heavy lifting. We know we're going to have x minus 1 squared, so y minus 35 is going to equal my 5 times x minus 1 squared, and then I just need to add my 35 to both sides. So now I have y equals 5 times x minus 1 squared plus 35. A is going to be 5. It's going to stretch my function. H is going to be positive 1. We're going to shift to right 1. K is going to be positive 35. We're going to shift up 35. The vertex here would be positive 1, 35. The vertex over here would be negative 4.5, negative 42.75. If you wanted to keep it decimal consistent. All right, hopefully that was mostly review and you know what's going on. If not, make sure you're asking questions and I will see you soon.